So continuing with the previous session. So in the previous session, we were discussing about the pointers. So here we will look into how to pass structures as reference or pointers. We already discussed about structures. So structure is used to access members. Okay. So here we have declared structure. Okay, this is structure with the name student and two members USN and name. Okay, so this is a user defined data type structure with the name student. So this is for storing the USN of a student and this is for storing the name of a student. Now we will see how to access the structure using the pointer method. Okay, so moving on to the main program. So here we have declared the variable of a structure. So this is a variable of a structure. Yes. Okay. Now here we have a printer statement printing the USN and the name. So structure student. Okay. So we have declared the variable yes and USN and name. Now we have already studied how to access these members using structure variable. So using the dot operator, correct? We have already discussed using dot operator we will be accessing the USN and the name using the structure variable. For example, scanf, okay, we are taking the input for the USN and the name yes dot USN and yes dot name. Okay, so here there is no ampersand because it is a string. Now we are calling the display function. So the definition of the display function is here. Okay, now we are passing the structure address of the structure variable. Okay, we are accessing and that address will be held, or the address that we are passing will be in the pointer. Okay, the pointer that we are declaring is star yes with the name yes. So address, so yes is a pointer which will be pointing to the structure. Now using this structure pointer, okay, you can see here this is a structure pointer. Okay, using this pointer, okay, we are not using dot operator but instead using pointer we have to use this arrow symbol. Okay, if I want to access a member using the pointer, remember we have to use a arrow operator. Okay, now to display the USN, I'll be using yes arrow USN. So it will display the USN, whatever you have entered. And also to display the name, you will be using yes arrow name. Okay, so be careful. So if I want to access the member using structure variable, I have to use a dot. And if I want to access using the pointer, then I have to use a arrow operator. So these two things you should be very careful. Okay, so now in the computer we don't have an arrow operator, correct? Now how to print this, arrow operator? Just use a minus. Okay, the minus symbol that you see in the keyboard and the greater than symbol. Okay, use these two. Okay, minus and greater than symbol to get the arrow operator. So this is output. So we are entering the USN as 101 and the name as Raj. So it will print. Okay, using the pointer we are printing the USN is 101 and the name is Raj. The next important concept is pointer to pointer. Okay, so we know a pointer. Okay, we have studied about pointer. The pointer will be having the address of a variable, correct? So if I declare a variable a and which is having some address 1000, and let us assume that it is having the value 5. Okay, and if I'm declaring a pointer, okay, then this pointer p will be having the address of the variable. Okay, now what we are doing is We are studying about pointer to pointer. What is pointer to pointer? Pointer that points to another pointer. Okay, if I declare one more pointer and if it is points to another pointer, okay, it is called as pointer to pointer. Now, if there is two pointer here, one is a p pointer which is pointing to the variable a. I'm declaring one more pointer q which is pointing to one more pointer. Okay, so this is one pointer and this is one pointer. Now, what will be the content of this pointer? Okay, so this pointer will be having the address of this pointer p. So let us assume that the address of this pointer variable is a 2000. Now this 2000 will be stored in this pointer. Is it clear? Now we'll be having a variable a which is having the address 1000. Okay, which is having the address 1000, and that 1000 will be stored in the variable pointer variable 1000 will be stored in the pointer variable p, and 2000 will be stored in the pointer variable q. Now how to declare this pointer to pointer? So this is the syntax we will be following. Okay, write the data type, okay, and use two double star, okay, two double star, and write the pointer name. For example, okay, if this is my pointer q and if it is pointing to the integer variable, then I'm supposed to write int star 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 q and semicolon. Okay, so this is pointer to pointer. This is how we'll be using the syntax for declaring the pointer to pointer. How to initialize? Okay, so initialization of the pointer is the same as the one we have studied. Okay, write the name of the pointer and ampersand and write the name of the another pointer. For example, here q is pointing to another pointer. How I'm supposed to write? Write q is equal to ampersand and write the name of another pointer, which is another pointer, that is p. Okay, so q is pointing to another pointer, that is p, and q will be having the address of p. So this is the example. So we have an example here. Okay, so there is a variable a. Okay, there is a variable a and it is having the value 10. Let us assume that it is having the address 1000. Okay, we are declaring a pointer p and we are declaring one more pointer q. Okay, now we are making the initialization of the pointer p. Now what we are doing, p will be initialized, okay, to point to variable a. So this pointer p will be made to point to variable a, so it will be having the address 1000. Okay, now again this pointer will be also a variable, it is also will be having some address. Let us take it's 2000. Now this q is made to point to not variable, but it is made to point to pointer p, because p is a pointer, correct? We have declared p as a pointer. Now what we are doing, q, okay, which is also will be having some address. So let us take it is having some address 2005, and it is made to point to this pointer p, and it will be having the address 2000. Now suppose if I print something like this, printf, okay, print a, then what is the content? So a will give you the output 10. The content of a is 10. Now if I write a star p, okay, this we already studied. So if I want to access the value that is stored in this address 1000, okay, then I'm supposed to write a star p. So star p will give you the value that is stored in the address 1000. So that is 10. Okay, so this is the new one. Okay, so pointer to pointer. If I want to fetch the value that is stored in variable a, then I'm supposed to write star star q. Okay, so So star q is something like this. Okay, I'll write something like this. Okay, first one is star q. What is star q? The value that is stored in the address 2000. What is the value that is there in the address 2000? That is 1000, correct? So this star q will give you the value 1000. And now you have star of 1000. So star of 1000 is the value that is stored in the address 1000. So what is the value that is there in the address 1000? That is 10. So this is how we are getting the value 10. Here, so I can write something like this also in the bracket star q. Okay, so which is nothing but first this will be give you the result 1000, star of 1000 will give you the value 10. Okay, so if I simply write here, okay, printf statement, and if I something write, if I write star q, you will get the answer 1000. Okay, just try. Okay, try by giving different printf statements. Okay, so this is how you will get the output 10 10 10. So if it all they write, then they ask in the exam, explain the pointer to pointer concept, you can give this example, simple example with the output. So next one is the difference between pointer variable and the normal variable. Okay, so here we have the difference between the pointer and the normal variable. So we have studied this, both the concepts, right? Both concepts we have studied: how to declare, how to initialize normal variable, how to declare and initialize the pointer variable. So pointer variable, first write the definition. Pointer variable will have the address. Okay, but whereas the normal variable will have the data. Write the example. Okay, general format of declaring the pointer, okay, which you already study, how to declare a pointer and how to declare a variable. Okay, you can write an example for this: int star p. So here int a. Okay, next one is initialization of the pointer. How will you initialize the pointer? P is equal to ampersand a. Okay, so normal variable, you just write a is equal to 5, correct? This is normal initialization of a normal variable. So variable is essential to access the data. Okay, so pointer variable, it is used to essential, it is used for accessing the data. So data can be accessed without dereferencing a normal variable. Okay, so we don't need any dereferencing operator or pointer variable pointer here. Without this ampersand, we can directly access the normal variable data. Okay, so here if I want to access, first I have to initialize, like this I have to write, then I have to access the data. Okay, write one example for pointer and write one example for a normal variable. Next, why we have to go for pointer concept? Okay, so pointer provide direct access to the memory. Okay, so memory is used for storing the data, and each data where we store will be having an address, correct? Now if I want to access the address, if I want to deal with the address, then I have to make use of a pointer. Okay, next advantages is pointer will take very less memory space. Okay, so one more advantage is it will take very less, pointer will take very less memory space. Next one is it reduces the complexity of the program. Okay, so using the pointer we can move to any memory address and it reduces the complexity of the program. Provides alternate way to access the array elements. You know, we have already studied how to access the array elements using pointer, correct? So you can also access the array element using pointers. Okay, you can also use a string, okay, pointer for accessing the string. Pointer can be used to pass information back and forth between calling functions. So you can also use the concept of pointers not only to the arrays, you can also use it in string, you can use it in structures, you can use it in functions. Okay, so This is the main advantage, some of the main advantages of pointers. Coming to the disadvantage of pointers. So pointers are not safe and insecure because the values of other variable can be accessed without permission. Okay, so it is not safe. We call it as pointers are not safe because if at all I know the address, okay, if I know the address, okay, I can access the data which is there in that particular address, correct? Correct. If I have a variable A and if I know the address of that particular variable A, then I can fetch the value that is stored in the address, okay, particular address. Okay. So that is why it is not safe. Initialized pointer might cause program to crash. Okay. Sometimes you are initializing a pointer to a particular variable and we are not using. Okay, in that case, it might cause a crash in the program. The pointers are slow than normal variable. Okay, the pointer will take less memory space, but it is slower compared to your normal variable. A pointers are updated with incorrect values. Okay, so pointers are pointing to some address, okay, which is not correct. Then in that case it might lead to memory corruption or memory crash. So these things you have to keep it in mind while dealing with the pointers. So moving on to the last concept of fifth module, preprocessor directives. Okay, so preprocessor directives is a program that processes the source code before it passes through the compiler. So what is preprocessor? It is also a program, okay, which is used to process your source code before it passes to the compiler. Okay, so we have already studied few of the preprocessors. Okay, so preprocessors are always starts with the hash symbol. So for example, hash include, correct? So we have already executed so many programs using this preprocessor directive hash include. Okay, and you know the what is the use of this, correct? Next is hash define. Okay, hash define. For example, your area of circle program, we have defined hash define pi is equal to 3.14. So wherever in the program you write this pi, okay, it will be replaced with the value 3.14. Okay, there are three types of preprocessor directives we'll be studying. So first one is macro substitution. Next one is file inclusion directives. Next is compiler control directives. So first moving on to the first one, macro substitution directives. Okay. So macro substitution is a process where an identifier in the program is replaced with the predefined string. So here we are writing, so this is an example for macro substitution where we are writing an identifier. Okay, that identifier in the program will be replaced with this predefined string. So I already given an example. Okay, let me give another example. So define max 100. Okay, so wherever in the program we have this macro max, it will be replaced with the value 100. Correct. So there are three types of macro substitution: simple macro substitution, argument macro substitution, and nested macro substitution. So these are some of the examples. Okay, this is example for simple macro substitution. So wherever in the program you have the value m, it will be replaced with the 5. Next, this is an example for arguments. Okay, macro with example arguments. So this is a function cube. The macro name is cube, and we are passing some argument x, and that, okay, for example, you are passing the x value is 3. So then it will give you 3 into 3 into 3. Okay, the value, okay, 3 into 3 into 3 will be given to this. Okay, I'll explain more about this with an example later in the next slide. Next one is nested macros. So nested macros, okay, so within one macro you have another macro, same as nested function. So this is a nested macro. So take an example, you have hash define yum, the value of yum as 5. Next, what you do is hash define, you define one more macro num, and that num is nothing but yum plus 5, that is yum plus 1, that is 6. Okay, so first you are defining a simple macro yum. Okay, next you are defining one more macro num, which is dependent on your previous macro. So this is called as nested macro. So this macro is nested within another. Okay, this macro is nested within your num macro. So here we have an example for macro argumented. Okay, so take an example, you have void main. Okay, you are calling a function with the two arguments 10 and 20. Okay, so we have defined the function here using macro min. So value of a is 10 and b is 20. So this is ternary operator, we have already studied, or conditional operator. Okay, so a is less than b, 10 is less than value of b is 20. Is it correct? Yes, 10 is less than 20. So in that case you are returning the value that is stored in the a. Okay, so the output will be 10. The minimum between 10 and 20 is 10. It will display the minimum between 10 and 20 is 10. So this is an example for macro argumented. So moving on to the next one, file inclusion directives. Okay, so this we have already studied. It tells the compiler to include a file in a program. Okay, so there are two ways. Okay, either you can write. Okay, so first I'll tell you the second syntax. Okay, this we have already studied, correct? If I want to include a file, okay, stdio.io.h, I want to include this header file. So what I'll be writing in the program hash include, in the angular bracket, within an angular bracket I'll be writing stdio.h, correct? If the file name is written within an angular bracket, then the file is searched in the standard director. Okay, directory. So when I write this statement, okay, your compiler will search for the header file stdio.h, and it will include this file before executing the program. Okay, so this is the second syntax. One more syntax. Okay, instead of writing like this, it is also possible to write like this. Okay, both are correct. Okay, I can write hash include in the double quote. I can write the file name. Okay, so hash include program1.h. So it will tell before executing the program. Okay, so include this program1.h. Okay, for example, one more example, hash include. Okay, so in the double quote we are writing, okay, stdio dot h. So including the file stdio.h. Instead of angular bracket, I can also write double quotes. Moving on to the third one, conditional control directives or compiler control directives. Okay. So this compile control directives allows you to include a macro definition or header file based on the condition. So it works. Okay. So it works based on the condition. Okay. So we'll discuss a few compiler control directives. The first one is hash if n def. Okay. So if I have this statement in the program, so it will check if the macro is defined or not. So n is for meant for not defined or not. Okay. So for example, I have these three lines. Okay. So it will check whether the macro, okay, so whether the macro is defined or not. Here the macro is test. Okay, it will check whether this macro is defined or not. Okay, so okay, now in the next line we have the definition. Okay, so previously this macro test is not defined, correct? If it is not defined, this statement will give you false. If it is not defined, okay, if this macro test is not defined false, okay, it will return you false. Okay, next, if it is not defined, then it will define the test macro with the value 10. Okay, so if it is already defined previously, for example, in the previous statement, I have something like this, hash define, okay, hash define test, okay, test 20. I already have the statement before this, okay. So my previous line was like this, okay, hash define test is equal to 10. So since it will next statement when you come, if not a defined test, it will check whether it is defined or not. Previously we have already defined test is equal to 20. So in that case, it will return you the value true. Okay, suppose if this is not defined, in that case it will give you the value false. Okay, it will check previously whether the test is defined or not. Okay, next you are defining. If it is not defined, you will define the test as 20 and write the statement end if. Okay, so this is about, okay, if n defined. Next is if defined. Next is one more. So this will check, this is also will check whether this macro test is defined. So if it is defined, okay, it will return you the value true. Okay, next you are writing undefined. Okay, suppose if it is defined, you are if the test is defined with the value 10. Okay, we have already defined the test with value 10. Okay, then this statement will 10, don't define test with any value. Okay, so one more, third one. Okay, hash if, okay, hash if 10 percentage 20. So 10 percentage is 20 is equal to 0. So 0 is equal to 0. Yes, the condition is true. So it will print the number is even. Okay. So this is something same as your if else statement. Okay. Suppose you have some value as 11. Okay, 11 percentage 2, it will give you the answer 1. 1 is not equal to 0. So in that case, it will go to the else part. So this is same as your if else statement, but here we are using preprocessor directives. Okay. So with the hash symbol, so something like this also you can write. Okay. So last one is used for printing the error message. If I want to print any error message, okay, then I can write it hash error and write the error statement. Okay, some error statement you can write. So this is all about preprocessor directives. Thank you.